Okay, so I'm excited to introduce our last speaker in the water session today, Camilo Rey-Sanchez, who is a professor at North Carolina State University and has been doing a lot of work with Ecostress, looking at ET in particular in corn and alfalfa fields. Welcome, Camilo. Great to have you here. And yeah, over to you.
Thank you, Trevor. Good morning and good afternoon, everybody. I'm very excited to be here today. Today, I'm going to present some of my work during my postdoc with Dennis Baldocchi at the Biomed Lab at UC Berkeley, where we were looking at combining Ecostress, CubeSights, and footprint modeling to improve the estimates of evaporation in corn and alfalfa fields. So as Mallory introduced, Ecostress is a remote sensor that is allowing us to have better mapping of evaporation. It's the ecosystem spaceborne thermal radiometer experiment on space station, as you can see it here in the picture on the right. And it's giving us that vital thermal infrared information that gives us that outward long wave radiation and that land surface temperature that is very important for evaporation models. It has 1 to 5 days overpass, and sometimes it can even give you images at different times throughout the same day. And it gives you information at 70-meter resolution, which is great. At the heart of the Ecostress products is the PTJPL model that models the potential evapotranspiration based on the partitioning of net radiation between the canopy, the soil, and it also allows us to calculate that interception evaporation from the canopy. And along with that, there are some constraints that basically reduce that potential evapotranspiration into actual evapotranspiration. For today, I'm going to focus on this one here, the green canopy fraction that is calculated as the fraction of absorbed power over the fraction of intercepted power. It's basically telling us how green is the canopy. And yeah, I'll be showing some details about these measurements later on, but today I won't be talking much about the other constraints. So we wanted to look at how these estimates of Ecostress evaporation compared to our ecovariance towers in California and at the Biomed Lab. So we selected 2 sites. One is the alfalfa, or the USBI1 site in Ameriflux, which is a site with periodic cuttings throughout the year, so lots of changes in that green canopy fraction. And the site at the bottom is a corn site, USBI2, which has a very short growing season from June to late September. So here's an image of the sites from Google Earth, along with a snapshot of Ecostress. And the first thing we wanted to do was to validate the estimates. And the first way we did this was to compare that average from that red square around the center of the tower and compare that to our ecovariance measurements. So what we got, this was over 2 years of data at different times of day. We found that there was some agreement, but quite a bit of noise. And one of the things I was really interested in doing was to evaluate if the footprint was actually going to improve some of these relationships. We know that footprints can be very dynamic and sometimes sample different areas throughout your tower. So when considering footprint weighted average, what I found was that there wasn't that big of an improvement, just a marginal improvement on that relationship between model and observed values. And one of the reasons for this is the resolution of Ecostress, 70 meters, and the footprint, as you can see here, that inner contour is the 50% footprint, which means that half of the sources are being located in about 1 or 2 pixels. So that's one of the reasons why the footprint is not very important here. But we know that when it comes to high resolution products, it should be important. So we were looking at these very high resolution products from CubeSights, particularly the Planet Fusion product from Planet Labs, that is giving us daily information at 3-meter resolution in 4 bands, red, green, and blue, and near infrared. And with this new Planet Fusion product, we're getting harmonized images that are harmonized with Landsat and MODIS images that are free of gaps and clouds, and they are highly consistent. Like, for example, let me show you here our alfalfa side. This is an image of the green chromatic coordinate that shows the greenness of the site. And you can see here that there is a very strong differences across fields, but also within the fields. So we know that footprints here should be important in calculating evaporation. More formally, we can evaluate other indices like the NIRV. This is the near infrared times the NDVI, which we know is a very strong predictor of GPP. And we know that considering footprint averages does improve this prediction, in this case of GPP. Okay, so how can we use this information to enhance the Ecostress PTJPL model? Okay, so one of the most important variables in this model is Fipar, the fraction of intercepted par, because this variable determines the partitioning of net radiation between the canopy and the soil. So here for this project, we collected direct measurements of under canopy par with these par sensors that you see here in the picture. And this allowed us to create this nice time series of Fipar and eventually find the strongest relationship of Fipar with our remote sensing indices from Planet Labs. In this case, we found that NDVI was the strongest. Another thing that we did by inspecting different remote sensor indices from Planet Labs was this observation on the comparison between GPP and NDVI. So we observed that the normalized GCC is a better proxy for Fipar than Fipar. So here, for instance, if you can see in the left, you can see that when GPP goes down, there is a lag response from NDVI. And this is related to the fact that in the reproductive stage of corn, the canopy is still kind of green, but the photosynthesis goes down. And basically, we found that this GCC star, or the normalized GCC, is a better predictor of that photosynthetic activity. So another way to look at this is to look at the comparison between NDVI and GPP on the left and GCC and GPP on the right. So you can see that if you evaluate NDVI, you see this hysteresis as a result of that differences in the reproductive stages of corn, whereas if you use GCC, you can find a very tight relationship, still with some hysteresis, but the relationship is much improved. So I'm going to cut straight to the main result here. We're finding that by using this CubeSats information, along with some of environmental drivers from our tower, we can improve these estimates by quite a bit. And further, we can see that when we use the footprint weighted values, we can further improve these agreements between tower and satellite measurements. Now, another thing that I wanted to evaluate was like what happens when we add the uncertainty of not having inputs from the tower and we use data from reanalysis, which is what we got to do if we want to scale to the whole globe. Well, we found that despite the noise in reanalysis data, we still have quite a good agreement between this approach using CubeSats and reanalysis data. So the relation is really good, or much better than the original Ecostress that you can see on the left. The relationships for corn were similar. We had a little bit more noise in corn, but we reduced the error quite a bit and reduced the bias estimate quite a bit as well. I'm going to skip the conclusions for now. Maybe you can read them later. And I'm just going to thank you for being here. And thank you to the Biomed Lab, particularly Daphne Sudu and Joe Verfali for collecting all this wonderful data, and to our funding sources. Thank you very much.
Thank you, Camilo. Yeah, very interesting to see this very detailed subplot dynamics. We have time for a question if anybody would like to raise their hand. I can ask one. I mean, oh, we have one hand raised.
Okay. One about the footprint. Oh, Paul. Yeah.
Oh, yeah. I was just going to ask quickly. In addition to the footprint question, this is a really great talk. Thanks for it. Do you know what the sort of the near-term future of CubeSats holds? Like, how many are being deployed in the upcoming years that we might be able to use for these applications?
Yeah. Well, I know this product that I introduced today, the Planet Fusion products, is fairly new, and I know that there might be some possibility to get some of this data for educational purposes. So you may want to check that. And but yeah, I think this is the future, right? Like daily data, 3-meter resolution, everywhere in the world. So yeah, it's very, very exciting for multiple applications, and for evaporation in particular, I think can be very relevant.
So we have a question from Jianming, our son. How do you calculate the footprint?
Right. This is a great question because we've done a lot of work on footprints as well. We did some trace gas release experiments to evaluate 3 different models. So we found that the model from Corman and Meixner is a very good model for our sites. So yeah, basically you take all the variables for the footprint, stability, roughness, U star, tower height, and yeah, you run this model and find the source area that those contours that I've been showing, that by the way were 50% and 80% contours. I think I didn't say that.
Thanks, Camilo. And then, okay, so one more question from Yanghui Kang, who's asking if there is a reference for the GCC index.
Great. Yeah. Thanks for that question. I didn't have time to introduce it properly, but the normalized NDVI, maybe you're familiar with this, is based on the minimum and maximum. This is the same concept for that GCC star, which basically we find minimum and maximum and normalize it. So that's kind of what I was trying to show today. But yeah, it's interesting that for corn, GCC was a stronger predictor of GPP, but if you look at alfalfa, the near NIRV, the near infrared times the NDVI was a stronger prediction. So that's interesting that it varies for different plants, and I think the value of this work also is to show that we can develop these specific relationships for different crops.
Thank you, Camilo. So we're at the hour. Just say for people interested in GCC, please do check out any work from the PhenoCam network or work using PhenoCams in general, as that's where it was first proposed as a normalized greenness index.